In this video, we're going to talk about API versioning. I'm going to explain what API versioning is, when you should version your API, and what are breaking changes. I'm also going to show you how to implement API versioning with minimal APIs, but don't worry, I'm also going to touch on controllers, and we have a lot of topics to cover in this video, so let's dive in. Let's start by explaining what is API versioning and why is it important when developing APIs. In simple terms, API versioning is about managing and evolving multiple versions of your API and communicating all of this to your API clients. Let me give you an example. Here is the post endpoint to create a new workout in our system. And let's say our API is being used by multiple applications that are integrating with this endpoint. And if we decide to make any breaking changes to this endpoint without communicating this to our clients and giving them a way to adapt to the new implementation, we're going to end up crashing a few applications. And this is something that we want to avoid at all costs. So this is where API versioning comes in. Instead of breaking the existing implementation to the create workout endpoint, we're going to create another endpoint. Let's say that this will be workouts version 2. And what we are going to do is introduce the new behavior in the version 2 endpoint. And then we're going to tell all of our clients, hey, the version 1 endpoint is no longer supported. You should move all of your API calls to the version 2 endpoint. There are multiple ways how you could implement API versioning. I'm going to show you how they look like from the client side, and for the time being we're going to get rid of our version 2 endpoint. Let me head over into Postman. When we introduce support for versioning our APIs, we need to tell the API which version of the endpoint we are trying to call. And there are multiple ways how you could pass this information, and I'm going to show you 3 of the most popular approaches. First, there is the query parameter versioning, where you specify the API version as an additional query parameter. You're going to use this on all of your calls to the API, and to change the API version, you simply change the API version query parameter value. So now I'm calling API version 2, and if I want to switch to API version of 1, I'm just going to update the query parameter value. The second approach to pass in an API version is using a custom request header. You can give it any name you want, let's say X version ID. It can also be called X API version, and you're going to pass in the API version using a custom header. On the server side, you're going to configure API versioning to fetch the API version from this custom header. And the last and probably most widely used approach is URL versioning, where you specify the API version using a route parameter. So let's say I want to call the version 1 endpoint. I'm going to specify the API version as part of the route. If I want to switch to a different API version, let's say version 2, I will just update my route parameter. So this is the approach I'm going to show you how to implement, but don't worry, I'm going to show you how to set up the other approaches. Now let's go back into the code and see what we have to do to introduce API versioning. I'm going to start by installing a few NuGet packages to my web API project, and I'm going to look for ASP versioning. You might be tempted to reach for the Microsoft package. Unfortunately, this one is deprecated, so you should be using one of the ASP versioning packages that you can see here. If you want to implement API versioning for minimal APIs, you should install the asp.versioning.http package. And this is the one that I'm going to install. If you want to add support for Swagger, additionally, you should add asp.versioning.mvc ApiExplorer. So let's go ahead and install that one. And if you want to use controllers, which I won't be doing, you would have to install asp.versioning.mvc. Now I'm going to install this library to show you how the configuration changes if you are using controllers, but everything else remains the same between controllers and minimal APIs. So with our NuGet packages installed, let's go back to the program file and start configuring API versioning. I'm going to start by adding the required services for API versioning. So I'm going to say builder services, add API versioning. And we're going to configure the API versioning options. So let's provide a delegate to access the API versioning options instance, and I'm going to start setting some properties. The first thing I want to do is to configure the default API version. You can provide a new instance of the API version type, and here you can specify what is the default version of the API. I'm going to start with a default version of 1. The next thing I'm going to configure is if I want to report my API versions or not. If I set this to true, API versioning is going to introduce a response header to all of my API calls indicating what are the supported API versions and what are the deprecated API versions. For minimal APIs, this isn't necessary because there is a different way to pass this value. Also, you can configure the API version reader, which is essentially how you set up which type of API versioning you want to use. And you do that by passing in an API version implementation. We're going to be using URL versioning, so I would pass in a URL segment API version reader. Now there's also a way to combine multiple implementations of this by saying API version reader combine, and then you can pass in a few implementations. For example, I want to support URL versioning and header API versioning, and here I can specify what is my custom header name. Now I'm going to revert all of this to just URL versioning because this is what I want to be using, but I wanted to show you how you can combine multiple API version readers. The next thing I want to do is to chain a call to add API Explorer, and here I can configure my API Explorer options. Two important things I want to set up here. First, I want to configure the group name format, and this allows me to tell Swagger what format my API version will be specified in. I'm going to use this template where the lowercase v stands for the v that I'm going to add in the route, and the uppercase v is a wildcard for my actual API version. Then I'm going to set the substitute API version in URL to true, and this is going to substitute the default API version in all of my Swagger endpoints. If you want to use controllers, the additional step you will need to take is to call add MVC, and everything else remains the same. I'm going to revert this change, and let's go to our workout endpoint and see how we would configure API versioning here using the URL route parameter. So I'm going to add a lowercase v and then a route parameter that I'm going to call API version. And you can also specify the API version pattern here. And this is how you set up URL versioning with minimal APIs. The same approach works for controllers. Now, the next thing you need to do with minimal APIs is to pass in an API version set instance. You would call the with API version set method and pass in an API version set instance. How you would get an API version set instance is by calling app, which is my iEndpoint route builder, and it has a new method that is called new API version set. Now I can chain a few more calls to configure API versioning. So I'm going to say has API version, and this allows me to specify what is the supported API version. So let's say that we support version 1. I can also configure what are the deprecated versions by calling has deprecated API version and passing in an API version instance. So let's say that we deprecated version 2, although it will make more sense to deprecate version 1 and support version 2. You can also configure if you want to report API versions by calling report API versions, obviously. And lastly, you can call the build method to get back an instance of your API version set. So I'm going to introduce a variable to hold my API version set, and now I can pass the API version set instance to the specific method on my minimal API endpoint. I could go ahead and do this for all of my endpoints in this class, but there is a better way to do this by creating a route group. So I'm going to say app map group, and I'm going to define a route prefix for this entire group. And here I'm just going to specify the part of the route containing API and the API version parameter. And the idea behind using a route group is now I can say with API version set and pass in the API version set instance for the entire group. Now I'm going to grab an instance of my route group builder, and this allows me to use the route group builder to map my individual endpoints. Let me map all of my endpoint instances from the route group, and then I'm going to update the routes for the endpoints. The route group will take care of the API and the API version parts in my route, and this is what I have left in my individual endpoints. In this case here, I'm going to get rid of all of this, and now I'm left with just referencing the workouts part of the route for my workouts endpoints. We also have another set of endpoints, which are the user endpoints, and we could use the same approach here with defining a route group and then mapping the individual endpoints using the route group, which will also take care of API versioning. However, there is a better way to approach all of this. I'm going to take this part of the code, setting up an API version set and the route group builder, and move it into my program file. We'll go back to our workout endpoints in just a moment. So let's define the API version set here. I'm going to map my route group, and I'm going to give it the API version set. And let's call this the versioned group. Now what I can do is use the versioned group to call my extension methods to map the user and the workout endpoint. Inside of my extension methods, I can just use the endpoint route builder instance that's passed in to map the individual endpoints without having to think about API versioning whatsoever. In the user endpoints, we don't need to make any changes other than removing API from the routes in the individual endpoint. So let's go ahead and fix that. And once we made that change, there is nothing else that needs to be done in the user endpoints particularly. What about supporting multiple API versions? Let's take this endpoint for example and create a copy of this endpoint. Then you can call the map to API version method and specify what is the concrete API version for this endpoint. Let's map this API endpoint to version 1, and this one we're going to map to version 2. To be able to use an API version of 2 in the first place, we also need to configure it in the API version set. So let's add another call to has API version, and we're going to say that we have an API version of 2. Now I'm going to start my API, and let's try calling the old endpoint from Postman without specifying an API version at all. So if I hit send, I will get back a 404 not found response because there is no route configured on our API without an API version. But if we specify the API version explicitly, let's say I use the version 1 for this request and we send this request, you will see that we hit a breakpoint in the version 1 endpoint in the user endpoints class. So I'm going to hit continue and we're going to get back some validation errors because I used an invalid request. Now if I update this to use the version 2 of our API and hit send, we are going to hit the breakpoint in the version 2 endpoint. And here we have the freedom to introduce any breaking changes that we want to. I'm going to hit continue and you will see that we get the same response back in Postman because there is no difference in behavior between these two API versions. But I want to show you the response headers that we get back and specifically the API supported versions header. You can see that we are supporting two API versions, versions 1 and versions 2, which is what we configured on our API version set. If you have more or less API versions, the value of this header is going to change, and if you have any deprecated API versions, they will also be reported in a specific response header. If I send a valid request to the version 2 endpoint, for example, I specify an email and a name, and I send this request, you will see that we get back a user. So let's take this user identifier and I'm going to use it in the get user endpoint version 1 to try to get back the user information. And you can see that we get back the response. If we take at the supported versions header, you will see that this API does support versions 1 and versions 2, even though we didn't explicitly create a version 1 and 2 endpoint. So if I send this request, you will see that we are still getting back a response. And if I use an invalid version, such as version 3, we are going to get back a 404 not found response. Let's also take a look at the Swagger user interface. You can see the Swagger UI here, and you will notice that there are only the version 1 endpoints. The good thing is that we are substituting the default API versions in all of our routes, and this is configured in our API Explorer options setup, but there are no version 2 endpoints even though we have multiple API versions. And here you can see that we are only supporting the API version of 1. So now I'm going to show you how we will fix this. We have to make some adjustments to our Swagger configuration, and I'm going to add a new folder where I will add a new class that will take care of this. So let's call this OpenAPI, and inside of it I'm going to add a new class that I will call configure swaggergen options. I'm going to use this class to implement the iConfigure named options interface, and the options instance that we're going to configure is the swaggergen options. Let's go ahead and implement this interface. You will see it has two methods. In the named variant, we're just going to call the configure method without a name and pass in the options instance. We're going to need to inject a service, and this will be the IAPI version descriptor provider. Let's go ahead and inject this from the constructor, and then I'm going to use it in my configure method to set up my swaggergen options. So I'm going to say for each, and then I'm going to use the API version description provider to get my API version descriptions. Then I'm going to create a new instance of the OpenAPI info object. So let's create a new OpenAPI info instance. And I'm going to set two properties on the OpenAPI info object. This will be the title and the API version. For both of these, I'm going to use the API version description object to take the API version value, and I'm going to assign this value to the respective properties. Then I can use my SwaggerGen options instance to call the Swagger doc method. We need to specify a name and an OpenAPI info object. So I'm going to use the API version description to pass in the group name, and then I'm going to pass in my OpenAPI info object. This is all that we need inside of this class. We also need to configure this with dependency injection. So I'm going to go back to our services setup, and I will say builder services configure options, and I can pass in my configure options implementation. We also need to update the call to use Swagger UI to configure the Swagger UI options. So let's provide a delegate to do this. I'm going to obtain a list of API version descriptions by calling the describe API versions method. We get back a read-only list of API version description objects. Then I can iterate over this list and get an instance of the API version description. And what I'm going to do here is to configure a URL to the Swagger JSON document for this particular API version. I'm also going to provide a name for this version and configure a Swagger endpoint for this version by using the Swagger UI options object and calling the Swagger endpoint method. Let's go ahead and run our API and see if this made any difference. If we take a look at the Swagger user interface this time, you can still see the version 1 endpoints are here, but notice that the URL has changed and it now specifies version 1 here, and in the drop-down you can choose between the different versions of your API. So if I switch to version 2, then we have the version 2 endpoints, and because I configured both of these versions to be active, then all of my endpoints have a respective version 1 and version 2. The one caveat to make this work is that you will have to configure your minimal API endpoints before you call the use Swagger UI method. This is because describe API versions can only figure out the supported API versions after you have already configured them. One more thing that you will have to fix when you introduce API versioning is your functional tests, if you have any. In this example, I have a few functional tests calling the user's endpoints, and none of my endpoints are specifying the API version. So let's go ahead and run the functional test that we do have, and you will see that almost all of my functional tests are going to fail. So what I have to do is to update my API route to also include the API version. So let's go ahead and fix our functional tests by introducing the API version. I also have one more test file, so let me specify the API version here and here. And now let's go ahead and rerun just the functional test this time. And you will see that our functional tests are now green and they all support API versioning. If you want to learn how to write functional tests in ASP.NET Core, then take a look at this video next. Click the like button under this video if you enjoyed it. Make sure to subscribe to my channel for more videos like this one, and until next time, stay awesome.